sensing capabilities into existing wireless communication infrastructure creates new opportunities for businesses and industries. This integration provides more efficient way to collect data and monitor systems. Businesses can make informed decisions, driving growth and innovation across various industries. One important application of integrated sensing and communication is drone detection. Drones are becoming increasingly prevalent, thus creating growing demand for reliable and efficient detection methods. Drone detection technology offers significant potential across various use cases, including improved public safety, enhanced airspace management, privacy protection, and security. Our 3.5 GHz 5G advanced massive MIMO test setup is used for wireless drone detection to demonstrate joint communications and sensing activities. This is the same test bed that our wireless research team has been using for field testing new communication capabilities. And now it is being reused for wireless sensing for aerial drone detection. It features a full duplex base station that can simultaneously transmit and receive signals achieved through radio frequency isolation in the uplink and downlink subpanels. For our drone detection test, a medium sized drone is flown in a hover mode across various locations within 300 meters from the base station. The drone detection process initiates with the full duplex base station transmitting a positioning reference signal targeting a range of azimuth and elevation angles. Simultaneously, the base station captures the reflected signals. The next step involves signal processing to eliminate background clutter and noise. Once the environmental clutter has been reduced, peaks in the reflections are identified along with their estimated range and angle. Lastly, microdoppler pattern of the detected peaks is analyzed, looking for unique signatures created by the micromotions of the drone in hover mode, such as vibrations or rotations. We observe 100% detection accuracy at distances of up to 300 meters. Furthermore, the range and angle of the drone is estimated with high accuracy. We have also conducted tests where we accurately estimated the speed of a drone in fly mode using its Doppler profile. Integrated sensing and communication has the potential to revolutionize how drones are used and managed, making them safer, more efficient, and more reliable, all while utilizing existing communication infrastructure. Ongoing improvements and advancements in this field will continue to bolster the capabilities of drone detection and tracking, making it an essential tool in the rapidly growing drone industry.